This is one of the biggest problems we have in the Netherlands right now. Or actually, this is. But we have found a way to make it the solution. Let us explain. You could say that the Netherlands is like a big farm. We use more than half of it for agriculture. This does make us the second largest food producer in the world, but it also has its downsides, namely in the production of greenhouse gases, and one in particular, nitrogen. And don't get us wrong, nitrogen in itself isn't the problem. Actually, approximately 78% of the air consists of nitrogen, but human activities have brought imbalance into natural amounts. Our project focuses on nitrogen in the form of NH3, which we know under the name of ammonia. This is the greenhouse gas that is mostly produced in agriculture, specifically by cattle, and more specifically by the dung of cattle. Here in the Netherlands, we have a poo problem. We produce 53,660,000,000 kilograms of cow dung every year. That's 53 million tons. It's a lot. The government has tried to manage the situation, but often caused more harm than good. So, we asked ourselves, what to do with all this poo? We looked for inspiration right at the source, the creator of our raw material, the cow. And we started looking, and looking, and looking, and then we found it. A pooping cow is like a living 3D printer. At that moment, the idea was born. We wanted to make a 3D filament out of cow dung. We saw a lot of potential in the material, and we fell in love with its unconventionality. But what to 3D print out of such an unusual material? In indigenous cultures, cow dung is used as a plaster for houses and even in the composition of bricks for adobe housing. This made us think of one of the most frequent news items in the Netherlands.
De Raad van State vindt dat de overheid kwetsbare natuurgebieden niet voldoende beschermt tegen stikstof.
Omdat Nederland al aan zijn stikstofplafond zat, mochten duizenden geplande bouwprojecten niet doorgaan. Nederland stond stil, met alle economische gevolgen van dien.
So, while we're in a housing shortage crisis, we are unable to build houses because cattle farming is already producing so much nitrogen. But then the question popped up. Could we 3D print houses out of manure? Would this offer a cheap and sustainable solution? We think it would. First, because it captures the nitrogen. Second, because 3D printing uses less material, less labor costs, and is a fast production method. And third, because cow poo is so abundant. We made a rough calculation which showed that we would be able to build approximately 1.5 million houses out of manure every year in the Netherlands. We thought that this sounded promising, and because it had never been done before, we decided to research how to 3D print houses out of manure. We started our journey cycling, as we do in the Netherlands, to the nature farm Hardebol, just outside of Amsterdam. We wanted to meet the local cows and ask them if we can borrow some manure. They said yes, so we put on our boots and cow shorts and collected some fresh cow dung. The farmers were friendly and quite intrigued by the project.
It's the most strange thing I have
Ever
done over here in this table.
First, we became familiar with the properties of manure. It is very lightweight, cellulose-based, negatively charged, hydrophobic, and dependent on the diet of the cow. To find the best possible recipe, we did some literature research and talked to experts about possible fillers and binders and the ratios at which they could best be used. And then we went into the kitchen to experiment with a 3D printing filament. We've tried out approximately 35 different recipes. First, we weighed the ingredients. Second, we put them together in a bowl and mixed them until we got a homogeneous paste. Then, for the next step, we put the paste into the whipped cream syringe. And last, we printed the paste manually with various nozzle sizes and layer height. We've tried to create a paste that is viscous but also strong when dried. After letting the samples dry for 5 to 7 days, it was time to test the strength, water resistance, and fire resistance. A building material has to go through a lot of regulations concerning these characteristics, so it was important for us to know. Although we didn't have the means to get some hard data on these characteristics, the results we have found are promising. We then collected all the results from the experiments to draw some conclusions. Eventually, we had 3 recipes we like to continue with. Each had a different binder: methyl cellulose, sodium alginate, and xanthan. and they all contained calcium carbonate and tapioca starch. These 3 recipes we wanted to test in the paste printer. It was hard to find someone that wanted to loan their paste printer to print poo with, as you can imagine, so we decided to make our own. We hacked the 3D printer into a paste printer by watching a YouTube tutorial, 3D printed the missing parts, and eventually assembled everything together. Once we had the hardware figured out, we focused on the software. We generated our own printing language in Rhino and Grasshopper, which gave us more control over the printing process. When everything was ready, we started printing with our 3 favorite filament recipes. It took a few tries to find the right viscosity of the filaments. On top of that, we had to find the best setting combination of layer height, printing speed, and extrusion speed. Only one of the 3 recipes checked all the boxes: manure with sodium alginate, calcium carbonate, tapioca starch, and glycerin. Of course, you can't do a project with cow poo without asking people what they think of it. Because of the smell, the interviewees immediately noticed that the sample was made of cow poo. Removing this smell is of course a very important next step in getting this material on the market. However, the interviewees weren't as disgusted by the material as you might think. They actually liked how natural the material felt. With some alterations and further development, they all thought that the material could be promising.
It's just poop. Yeah.
And the journey doesn't end here. There are still so many things we would love to do, like testing with different cow dung consistencies, perfecting the filament recipe, researching how to best capture the nitrogen in the building material, and, very importantly, looking into appreciating the cow and making sure it will benefit from this project, so we can eventually 3D print eco-friendly houses out of cow dung. And come on, wouldn't you want to live in this?